Alrighty, so let's go ahead and finish up lesson 4. I've already done the shading for these two. So if you need to shade them, go ahead and shut off your video and shade them in. But I just wanted to have that done so you didn't have to sit and watch me try to stay in the lines with my markers. So 3/5 of a pizza, and here we have 5/8 of a pizza. So shade figure 1 to represent the 3/5 of the pizza that Josh ate. So let's go ahead and write Josh down there. This looks really blurry. I'm going to fix it a bit. There we go. So this is Josh. And shade figure 2 to represent the 5/8 of a pizza that Chase ate. So this is Chase. Is it clear which shaded region is larger? So can you tell who ate more by looking at this? Why do you think it's complicated? Why is this one so hard? It's because the holes are not divided up the same, right? If they would have made this 5/8, we'd be able to tell right away. So we should say the units or the holes are not divided in the same manner. That's why we can't tell by looking. So they made the units the same size. One is still one, but it's how they divided it up, horizontal stripes rather than vertical stripes. So they either need to both be horizontal, which would be kind of hard, but the best way would be to make them both vertical. So let's just say it is hard to tell since the units, and whenever we use the word units, that just means the whole. Since the units are divided differently. It is hard to tell since the units are divided differently and we cannot compare the shading. Because before we could compare the shading, unless they were really, really close, and tell who had more. Like the last one that we did, the candy bar problem, that was pretty hard. We could narrow it down to 2, but it was pretty hard to tell. So it's hard to tell since units are divided differently and we cannot compare the shaded regions. But since the holes are the same, that's going to allow us to compare the fractions. So let's go ahead to the next page after you get that written down and compare the fractions. So we have 3/5 and we have 5/8. So let's go ahead and skip 2. If we had to use that there, I don't know how we would do it. If we had to use that picture, maybe cut them up and lay the pieces on top of each other and see which one had bigger pieces. I don't know, but we're not going to do that. We're talking mathematical here. So to find the mathematical way, we would have 3/5, 5/8 over here. So what's the common denominator? 8 times 5, 40? 40? So in order to make this first one 40, I would have to multiply 5 by 8. But whatever I do to the denominator, remember I have to do to the numerator. So 5 by 8 is 40. 8 I would have to multiply by 5. So whatever I do to the denominator, I also do to the numerator. So we get 24 and 25. Whoa, those were close. I didn't realize they were so close when we were looking there. That means if we had a pizza divided into 40 pieces, one person got one more. So, and the pieces, think about it, would be so tiny. That's why we couldn't tell by looking at that picture. But now we can say 5/8 is larger because its equivalent fraction, 25/40, is larger than 3/5 equivalent trying to keep it all in and right. I guess I should quit writing so big, shouldn't I? 5/8 is larger because its equivalent fraction, oh wow, 5/8 is larger because its equivalent form, 25/40, is larger than 3/5 equivalent form, and 3/5 was 24/40. So good thing I proofread that one. That was a mess, wasn't it? 5/8 is larger because its equivalent form, 25/40, is larger than 3/5 equivalent form, 24/40. So which fraction do you think is greater and why? Yep, we answered all the questions. I'll make that a little bit smaller so you guys can copy all that at once if you didn't get some of it. Okay, so if you need another minute, just stop the video and you can copy it if you need extra time. Okay, I'm going to make it big again. Let's go to the last page. We're not going to do the very last page. It's something about making up stories. We don't need to make up stories. So we're just going to do this one page and we're going to skip that last page. It said something like make up scenarios. You can save that for storytelling class. So let's do this last page and we'll be done with lesson 4. So how do you compare one fraction to another fraction? Create fraction comparisons of your own in the boxes below. In box 1, show that the fraction on the left is less than the fraction on the right. In box 2, show that the fraction on the left is greater than the fraction on the right. Use what you have learned today to explain why your comparisons are correct. And then we're not going to do this. So on the back of this, create scenarios. Okay, so we'll just cross that out. We're not going to do that part. So how about we do our same numerator, same denominator thing? This will be good practice. So let's take two fractions with the same numerator. 3/5, 3/4. So remember what I said, when the numerator's the same, the best way to compare them is decide which one's closer to a whole. This one, 2/5 is missing here, only 1/4 is missing. So does everybody agree this is closer to a whole? And do you also remember that fast little trick I showed you in Module 2? This is 12, this is 15. You know that. So when you cross multiply 12, you put it by the top number, cross multiply 15, and that will also tell you which fraction's larger. We don't need to use that here, but that is a method that we can use if we're really stumped. Just cross multiply, put it there, cross multiply, put it there. And the reason I don't teach you just that one, because I think it's awesome, is because what if we're comparing 3 fractions? Then what are you going to do? Or 4 fractions. So then you have to know how to find a common denominator. So I would just use this one in emergency situations. Most of the time, either use the rules. If the numerators are the same, pick the one that's closer to 1. If the denominators are the same, pick the one with the largest numerator. So we know 3/5 is larger, and remember the rule, it eats the big one. So that means, I just said that backwards, I'm sorry. We know that 3/4 is the one closest to 1, and it eats the big one, so we need to put 3/4 over here and 3/5 over here. Also, a way to remember it, besides the fact that it eats the larger fraction, is L means less than. So 3/5 is less than 3/4. Okay, so we're just going to write y. So for number 1, when the numerators are the same, and remember, this trick only works when the numerators are the same. The largest fraction will be, largest fraction, fraction will be closer to a whole. Will be closer to the whole. When the numerators are the same, the largest fraction will be closer to the whole. Okay, now let's do one where the denominators are the same. So let's do 3/8 and 5/8. Okay, so we all know 5/8 is larger, right? It's closer to the whole. And when the denominators are the same, we pick the largest numerator. So 5/8 is larger, so it eats the big one. So this is going this way. So that means the 5/8 has to be here and the 3/8 here. And also remember that this is not an L, it's backwards, so that's why we know it's greater than. When it looks like an L, it's less than. When it's not an L, it's greater than. So for scenario 2, we learned that when the denominators are the same, the fraction with the largest numerator is the largest fraction. So when the denominators are the same, the fraction with the largest numerator is the largest fraction. Okay, so that was from our earlier lesson. This was just a way to summarize what we learned in this lesson. And like I said, this lesson was a review from Module 2, so you guys can probably fly through Alex and not have any problems with this. So that's why I kind of went fast through the notes since you had seen it all before. Okay, that'll be all for Lesson 4. I'll start Lesson 5 on the next video. See ya.